Last week I covered the first steps in refactoring a data science project. In today's video we're going to take a closer look at how data flows in the application and how we can use design principles to improve that. If you want to learn more about data science, Skillshare, who's the sponsor of this video, is a great place to start. Skillshare is an online learning community with thousands of inspiring classes for creators. Explore new skills, deepen existing passions, and get lost in creativity. Skillshare has many classes on web development, programming in Python, software engineering, and software design. At the moment, I'm following Frank Kane's course on data science and machine learning with Python. It's really comprehensive. It contains lessons about statistics, data types, clustering algorithms, decision trees. It covers libraries such as pandas, basically everything you need to know in order to get started. Skillshare is curated for learning. There are no ads and they're always launching new premium classes, so you can stay focused and follow wherever your creativity takes you. The first 1,000 of my subscribers to click the link in the description will get a 1-month free trial of Skillshare, so you can start exploring your creativity today. So a quick overview of what we did last week. So we have this main.py file that actually runs the experiment, and we have a source file that contains all the specific code. So we did a few things. One is that we refactored the whole tensor board and coupling with the experiment tracking. So we created a protocol class called experiment tracker that has a few methods to handle all these different things. We have a tensor board experiment class that follows this implementation that we're then using in the main file. And finally, we switched the linear net class to use a network instead of a sequence of explicit function calls and storing them into the variable instead of using something like function composition, which I also talked about. Today, I'll start by looking at the metric class. So the metric class is used to keep track of ongoing data while you're running the experiment. You can see this happening here in the main file. We're creating these metrics, so these are accuracy metrics, and every time we're running one of these loops, we're basically we're updating the values in these metric objects. I think conceptually that's nice that you have a separate class, a separate object that keeps track of that and that you can then pass to the experiment. It's a class that contains these class member variables, so that means that these are not specific per instance, but in the main file we actually have multiple instances of these metrics. So this potentially leads to problems where we think we update an attribute of a class, but that's actually not what we're doing because these are class member variables. So we need to fix that. And the way to do it is to basically turn this into a data class. That's the most simple way to do it, because then we can just use this as the data class members. And then the data class package is going to turn these into instance variables for us. So let's turn this into a data class like so. And that also means we need to import data class. So we're importing data class. There you go. Now the thing that we'd like to do is that if you look at the initialize method here, which is not needed in the case of data classes, that it actually resets itself to a bunch of initial values. Now with data class, the way you do it is using the assignment like so. So I'll do the list in a minute, but I'll first do these values. So these are all just 0.0 like so. And then I can remove the initializer here. But now in this case, ideally you'd want to do something like this. But that's actually not allowed in the case of data classes. And that has to do with how values are initialized. But for example, if I try to run this, you're going to see I get a value error here. And that's because I can't use the list class for a field value in a data class, because lists are mutable. It's actually a really easy way to change this. You just need the field function from data classes, and then we'll write here that this is a field, and we provide a default factory, which is a list. So this tells the data class that it can use the list initializer to initialize this value. And now when I run the code, we don't run into that problem. It's validating and training again. Another thing is that if you look at the rest of the metric class, so because it's now a data class, we don't need this string representation anymore. Data classes already does that for us. And then there's one final thing. So there's an update method, which is useful. And there is a reset method. But actually what the reset method does, it basically completely reinitializes the object. A much simpler way to do this is actually to just create a new object, because that does exactly the same thing. So I could just remove this reset function here. So now the metric class is really simple, really clean. And then here, obviously now we're going to have some errors because there's going to be a call to reset. So now instead of resetting the metric, I can simply assign it a new instance of the metric class, and that's going to do exactly the same thing. Gonna run this again. And this is still working. So by doing these simple things and relying more on Python syntax, you can really simplify a lot of the code and make things a bit more easy to change later on. On this channel, I talk a lot about software design patterns and design principles. And there's one design principle that's in particular important for data science projects, and that's the information expert principle. It's part of the set of principles called GRASP, that's been proposed by Craig Larman. According to this principle, you should assign responsibility to the information expert. In other words, the part of the code that has the information necessary to fulfill that responsibility. You could also say that the design of your software should follow the structure of the way that the data flows. So now let's dive back into the code and investigate how data flows in the application and how we can improve this. Let's take a closer look at the main.py file. It basically contains all the code that's needed to run this experiment, but that also means it has quite a lot of different responsibilities, and that's not such a good thing. So I'd like to separate out these things a bit more. And what's really important when you're doing this kind of separation is to clearly think about where you're storing what data and which part of your program needs what type of data, because that's, in a data science project, for a big part, determines how the code is going to be structured. So if you look at this code, you see that there are some objects that are being created here. And then here we're running for each epoch, we're running a sort of testing loop and a validation loop. You see there's a lot of duplication here. So we're keeping track of a test batch number, that we're also keeping track of a train batch number. The sequence here is almost the same, you know, if you look at this part, for example, and this part, apart from some values are going to be different, but basically we're doing some computations, then we're retrieving metrics of those computations and storing them in the experiment tracker, and then adding them here to our batch data, which then at the end is also stored in the experiment tracking system. So what I think would be nice is if we can create a runner class that can perform basically this job for us. And then we have a few settings that we can change so that it can cover the testing case and that it can also cover the training case. And that makes the code a lot shorter and a lot simpler. What I'm going to do is create a file here called running.py, like so. And that's where we're going to create our runner. So let me just create a simple class here called runner, like so. So that's going to contain our actual runner that's going to run this training loop for us. And that will need an initializer, which obviously gets self. So what can we do in this initializer? Let's look again at this main.py file. So you see that there is some data that it keeps track of that we can actually store locally. We don't need to do that here in the main part. For example, there is a counter of at which run you're at, so it makes sense to actually store that inside of the runner. So I'm going to add here a variable called run count, and that's going to be initially 0. So another thing that main is going to need is a loader. So in this case, this basically loads the data for us that we're going to need in this loop. So in this case, this is a test data loader, and if you look here below, we have a training data loader. And these are actually data loaders from PyTorch. So that's another thing that we're going to need. So there will be a loader. And this is something that we'll need to pass as a parameter. So I'll just call that loader, and then we're going to add that here as a parameter. So loader, and that's a data loader. And in order to avoid any issues with types, we also need to specify the type of data loader. And for now, I'm just going to put any in here. To keep things simple, you could also specify a more precise data type if you wanted to. So let me just import the data loader from Torch. There we go. So now we have the data loader, and we also need to import any from typing. So we can actually use that as well. So one other thing we're also going to need in the runner is the model, because you see that it's being used here. And model, that's in this case, that's basically the linear net that we find in this file. Let's add that here as well. And model, we can make that generic, because if you look at the model here, you see this is a Torch module. So we can make model actually a Torch module. Oh, this should actually be a parameter. So let me put it here. So that's a Torch module. There we go. Let's store that also here. Model equals model. There we go. And this should not have a comma. I'm mixing up parameters and statements for some reason today. All right, if you look at the loops here, you see that the testing loop doesn't need the optimizer, but the training loop does use it in this second part here. So we're also going to need the optimizer if you want to turn this into a generic runner. So let's add that optimizer here as well. And since we're not really needing the optimizer in all cases, because we don't need it for testing, this could be an optional thing actually. There we go. So now we have the optimizer, and let's also store that in the object. So now we have the runner that's initialized. There's a few other things we should do here as well in order to prepare for running this loop. So one thing we're going to need is this compute loss function. You could also pass it as a parameter here, but for simplicity, I'm just going to create it inside the runner itself. So I'm just going to copy this line here, and I'm going to the running part, and then I will store it here as well. There we go. And then you see we have a few containers here, and these containers contain batch data, and they need to be reset for every batch. That's actually a bug in the original code, because for every time you run an epoch, you need to clean out these lists of batch data, because otherwise results from the previous epoch are going to be part of the confusion matrix of the next epoch. So these things we can also put them into the runner class, and then let the runner class take care of setting and resetting them. So I'm copying these, and then I'm going back into the runner class, and then I will paste these here, and let's move that to the right indentation level. There we go. And then let's put a self dot in front of that there. So these things are basically arrays that we're going to use to keep track of the outcome of the experiment. And we can also create a type here. So these are arrays of arrays basically. And I'm just using the any type for the moment, but if you want to have more precise specification of what your data looks like, you can change the type later on. So there, that's going to be the same thing. So that's the batch data. And then finally, what we can also do is keep track of an experiment stage, basically. And that's either training or validation. So what we can do is we could assume that the stage is based on the presence of the optimizer. And you might want to do this differently. You can also set it explicitly, but let's just do it like this to keep things really simple. So we have a stage, and that's, I want to import stage, and that's validation if if the optimizer is none, because as you can see in the main file, if we're in the validation part that's here, then there is no optimizer, and otherwise it's going to be training. Dot train. There we go. So now we also have a default value for the experiment stage, which is useful. The final thing that we need here, and that's also part of the runner, is the metric. So you see we're creating one for the trainer and one for the tester. So we can actually just put it into the runner. And then afterwards we can create a train runner and a test runner. So let me put that here. And let's call that an accuracy metric, which is an instance of metric. There we go, instance of metric. And it's automatically importing these things, which is really useful. So that's the initializer. Still quite a lot of code, but at least we're doing it only once and not twice for each of the separate things. Then the next part is that we're going to need to run the experiment. And running basically means that's this part here, this loop here, that's running it. So what I'm going to do is I will copy over this particular loop because that also contains the optimizer. So let me copy that, and then I'll create here a run function like so, and then let's copy over this whole part here, and this needs to be indented, obviously. We're missing some imports. We're going to need TQDM. I'm not exactly sure what that is, but if you're a data scientist, I'm sure you know what it is. So I'm importing that here. And now you see we're missing some other data here as well. So in this case, we don't want the train loader, but we want to use our loader that we stored here. So this is going to be self.loader. You also see that it needs a description. We don't have a description here, so let's assume that we will pass it as a parameter here. So this is a string, and then here we can put in the description. In order to separate this a bit more, I'm going to move all this code to a separate method so that we can have a bit smaller, more comprehensible methods. So let me do that by adding here another function that, let's call that run single, and this is just something that we're going to call from inside the class, so it's not supposed to be public, so I'm putting an underscore in front of it. Self, and this is going to get an X and a Y, which is these X's and Y's that we see here. So there we go, and now I can reduce indentation again. So the first thing we're going to do is increment the run count, and that's self.run count. And let me first actually call this run single method here. Run single, and that's going to get an X and a Y. So let's also, since we're not doing specific things to training anymore, let's change this to an X and this to a Y. There we go. So then this is our run method. And then let's go through the run single method and update all the names here. So this is going to be an X. Let's just call this batch size. There we go. So that's batch size. And then this is going to be the prediction. There we go. And this is the model we have here. And that uses the X. And then we also have the loss that we compute here. So self.compute loss. And that gets the prediction and the Y value. Then we're going to compute the batch metrics. So let's also here change the names of these things so that they're no longer specific to training. And let's call this simply batch accuracy. There we go. Accuracy score is a function that we need to import from scikit-learn. So that's this line. Let's paste that here. And we also need to import numpy. There we go. It's always a challenge to keep these imports up to date. So you see what makes this quite hard is all the typing issues that we get. Especially when you're using lots of different libraries, this is really a challenge. So for example, accuracy score returns something called any, but that's going to result in trouble later on. So we know the type is a float, so I'm just going to write that down here explicitly so that it results in less problems later on. And here we need to update the metric. So the metric we stored also in our runner object, that's accuracy metric. So let's also change this to self.accuracymetric.update. I'll talk about the experiment in a minute. I'll just finish this part, which is the optimizer. And this we only need to do if there is actually an optimizer. So let's add an if statement here to cover that case. So if there is an optimizer, then we're going to do this. The loss value we got here, so that's fine. And then we have the self.optimizer.step. And then finally the experiment part. So this is actually the part where we're communicating the updated information back to the experiment tracker. So I'll remove it from this part of the code. There we go. And then I just put it here inside the for loop. Actually, there's one thing I'm going to change. So with the experiment, I'm going to assume that the stage will be set outside of this so that there's something else that controls the stage of the experiment. And the only thing that I'd like to do here is then add metric data after we've run this particular loop. So I'm going to add this batch metric accuracy, and then this thing, we're actually going to need that as a result from running the single loop. So this needs to return the batch accuracy in the end. And then we can store it here. And then we have it here. And this is actually the run count. There we go. And now the only thing we're going to need is the experiment. And that we're going to get as an parameter here. And this is of type experiment tracker. So now we've reworked the way that this code is structured in the main part and kind of organized it into a runner class. So now the main file, what we can do is shorten the code here and create runner objects and then use those instead. So let's do that. So one thing I am going to do as well is create a main method, because I think overall it's just a lot cleaner. So I'm just calling that main, and all this stuff is basically going to be in main, and then I will add here if name equals main, then we're going to call the main function so we won't pollute the global scope. So now in main, what do we need to do? Well, let's see, we have the data here. We have the model and optimizer, the compute loss function that's actually being done in the runner. So let's write here a few lines to create the runners. So let's call that a test runner. And that's a runner. And a runner gets a few things. It gets the test loader and it gets the model. And in the case of the train runner, it's going to get the train loader, the model, and the optimizer. There we go. And runner we can automatically import here. So now we have our runners, and we can throw away a couple of things. So the metric containers here, we don't need them anymore. We still need the experiment tracker, obviously. Batch counters, we don't need that either. So then we have these two loops, and now we can use the runner to actually perform these two loops for us. So how does that work? Well, we have the testing loop and the training loop. So let me just add this here. So the first step is we can set the stage in the experiment. And that's let's say we start with the training stage here. We're going to call the run method on the train runner. And let's say we're calling that train batches. And it also needs the experiment. So that's the run method there. And then we have the test runner where we need to do exactly the same thing. now that we've done, and this also needs the experiment, obviously. So these two things basically perform these entire run for us, and then we still need to add some extra logging. And that's basically the things that you see here. So there's one more thing that I'm going to do to make this a little bit easier, and that's in the runner class, that I'm actually going to add a property to compute the average accuracy for me. And that's accuracy metric dot average. So this is going to give us the average accuracy, and this is actually a float. So let's also add the type int here. So that's average accuracy. And then in main, I can start logging these things. So here's the training logging part, and this is called epoch. And let's also add the validation logging part. And then this stuff we can all delete here, because that's all part of the runner. Let's first move this up here, because that's also logging something. So there we go. And then these things we kept track of in the runner class, so we can get them here from the runner. And that's the epoch. And then this we can delete here. So we can reset the runner at the end of each experiment. So that means we need a new accuracy metric, and we need to clear the intermediate batch data. There we go. And this one as well. And then in the main part, we can simply reset this thing by calling that here. So here I'm going to add this, and that's test runner reset and train runner reset. There we go. So we're resetting the runner at the end of each epoch, basically. So let's move that summary up here. So we're going to do that before you reset the runners, basically. And now we still need to have this average accuracy, and I made a property for that. So I could change this to be the test runner average accuracy. And then let's remove all this stuff. There we go. And this is the train runner average accuracy. There we go. And then these ones, we can simply remove them because that's no longer needed. So let's see, where are we now? This one, we don't need it anymore. This one, we don't need it anymore. So you see, we start to get rid of a lot of these imports in the main part, which is a good thing, actually. There we go. And now let's run the code and see what happens. Oh, I think I forgot something here, and let's go back and try that again. Yeah, so now it's training and validating again. We now have a basic runner class that we can use to simplify the main.py file. I'm going to finish this project next week and use the runner class as a starting point for that. And I'll also look a bit more into where we're putting configuration data and settings. I hope you enjoyed this second part of the refactoring. If you did, give this video a like. Consider subscribing to my channel if you want to see more of this type of content. Thanks for watching, take care, and see you next week.